Welcome to Coach O's Math. Today we're going to have a quick review before we get into evaluating square roots in expressions and then solving using square roots with equations. So the first thing is we're going to do a quick review with square roots, and I want to know that you should be able to identify if the square root is a rational or an irrational number. We've been talking about that quite a bit. I got to get my marker here. We've been talking about that quite a bit, and what is a rational number? That's right. It's a number that can be put on the number line that's expressed as a fraction. It can have a decimal that repeats, like 0.333 repeating or 0.666, because there are fractions that represent that, 1/3 and 2/3. Or it can terminate, like 1/4 is 0.25 or 0.25, and all of that can be found exactly on a number line. Irrational numbers are basically when we take the square root of a number that doesn't have a perfect square and there is no pattern. There's no repeating pattern. It just goes on and on. Pi is similar. What is a real number? That's right. A real number is made up of both rational and irrational numbers. They are all on a number line. The difference is we know exactly where rational numbers are, but we don't know where irrational numbers are exactly. We have an idea, but not exactly the place. Also, you should be able to tell me between what two numbers is the square root of 52. Because if we could take the square root, between what two numbers is that between? Well, it's between 49, right? And what's the square root of 49? 7. And it's between 64. And what's the square root of 64? 8. So we went over this. So if I ask you between what two numbers is the square root of 52, you would say it's between the two numbers 7 and 8, not 49 and 64, because you'd have to evaluate the square root of 52. I'm kind of rushing through this, so this should be our review to you. If I ask for the two square roots of a number, and I just give you a number and I say, like, what's the two square roots of 121? You should know that the answer you can write is plus or minus 11, because if we square 11, 11 times 11 is 121, and if we square negative 11 times negative 11 is also positive 121. So that if I ask you for the two square roots of a number, then you should be able to tell me that it's both positive and negative. However, if I ask you to evaluate a square root, and I say the square root of 25, they're telling you they only want one root, the square root of 25, which is positive 5. Here, they want to take the opposite of the square root of 36. But they only want one square root. So the opposite of the square root of 36. Well, the square root of 36 is 6. And the opposite of that is negative 6. Because if I square negative 6 times negative 6, I get positive 36. Okay. So now we're getting into evaluating expressions, I believe. Let's get this down. Yeah. So now we get into where we use variables. And so evaluating expressions should be nothing new. We use the what property. For some of you, that's right. And for some of you, a little bit rusty, the substitution property of equality. So we tell you what the variable stands for, what number, and you replace the variable with a number. Remember, I like to use parentheses. So if I say the square root of 13 minus x, and x is 9, you would have to show me 13 minus 9, right? The square root of 13 minus 9. Well, 13 minus 9 is 4. We work inside out, so it would be the square root of 4. Because there's no negative, it just wants one answer. So the answer is 2. Remember, we don't put an equal sign because it's not an equation, it's an expression. So we'll put an arrow, meaning therefore, or you write it underneath. Here we have 13 minus xy. Remember, xy means to multiply x times y. Now, this one's tricky. So we go the square root of 13 minus, well, x is 9, but y is negative 4. We work inside out, order of operations. We bring down our 13 minus, and then 9 times negative 4 is negative 36. So we write negative 36, but then we have 13 minus negative 36. When we have two negatives minusing a negative, it becomes a plus. So 13 plus 36 becomes 49. So the square root of 49 is 7. So I want you to try these two right now. So pause the video and use the same two values for x and y and solve for the square root of 2y plus 17 and the square root of xy plus 52. Remember to put parentheses around the numbers, each number that you're replacing the variable with. Welcome back. Let's see how you did. All right. You substitute a -4 for y. You get 2 times -4 is -8. Order of operations. You do multiplication before you do addition. And then you get the square root of 9, and the answer should have been 3. Here, xy becomes 9 times -4, which is -36. And -36 plus 52 is 16. And the square root of 16 is 4. So hopefully you did well on those. This is what we're going to be working on in class tomorrow. All right, now these. Now we're going into solving equations. Equations, we use the square root sign to solve. We're getting ready for solving for Pythagorean theorem, and you have to be able to show this step. So if I tell you a squared equals 64, you have to say, well, how do I solve that? I have to have a by itself to the first power. Well, we just learned about square roots. So remember, whatever we do to one side of the equation, we must also do to the other side of the equation. So we take the square root of both sides. Remember, whenever you take the square root of a variable, the square root of a squared is a. And the square root of 64 is 8. And the way you check it is, you substitute 8 for a, and a squared is 64. Here is a little trick here. You're going to divide. This is like solving a one-step equation where we had 3x equals 75. But we have 3x squared. But before we can take the square root, we have to divide both sides by 3. Remember, to isolate the variable. So we get x squared equals 25. Now, look, there's a pattern. We're going to take the square root of both sides, and we get x equals 5. Here, c squared minus 4 equals 5. What are we going to do? Solving equations. Go back. What do you do to solving equations? First, you add or subtract. Then you multiply or divide to isolate the variable. So we're subtracting 4. How do we move the 4 to the other side? That's right. We add 4 to both sides. We get c squared equals 9. The 4's cancel. Remember, you do the inverse operation of what's being done. If I'm subtracting 4, I have to add 4. So now we're back to this. What do we do to both sides? We take the square root of both sides. So c equals 3. Here's a little trickier. What do you do first? You're going to isolate the variable. Well, you're adding 7, you're subtracting 7. So the inverse operation of subtracting 7 is adding 7. This is how you have to show your work. We bring down the 2x squared, and we get 98. Okay. We still have to isolate that variable, even though it's x squared. So we're going to take the coefficient of x squared, which is 2, because you're multiplying it, and you divide both sides by 2. So x squared equals 49. Now this looks like this. So now we just take the square root of both sides. It's a pattern, and you're starting to do one step harder every time. One step more to solve. But basically, once you get the basic steps, you're using just like when you solved one-step equations. Now, I want you to pause the video, and I want you to try these. Same thing that we just did, same types of problems. Welcome back. Let's see how you did. Well, you should have taken the square root of both sides, showing your work, and got x equals 7. Here, you had to divide both sides by 2 before you even started. X squared equals 16. And then you took the square root of both sides. X equals 4. Here, you were adding 15. You need that d on a side by itself, the d squared. So we're going to subtract 15 from both sides. And we get d squared equals 81. What do we do? Take the square root of both sides. D equals 9. And then this one, we're going to add 2 to both sides, because we have to get rid of that 2, take it to the other side. This is just manipulating the equation. Bring down the 2x squared and 200. Divide both sides by 2. X squared equals 100. X equals 10. Now, this is what we're going to be working on in class. Good luck. Write down 2 things that you learned and 1 question you'll see you still have, and tomorrow we'll talk about it in class. And I'll see you then. You guys have a great day, and let's have a great, strong finish to the year. Bye-bye.